Hey, I'm Courtney Waterman, your tutor. Lover of anime, manga, and math. And you just tuned into another session of Tutor Me Sempai. Welcome back, everyone. Today we're jumping into a 6th grade topic, finding your variance and your standard deviation. Now, if you're new to my channel, I put timecodes in for this video in the description box below, so use that to skip ahead to whatever part of the video you think is most interesting. As always, if you have any questions about what we see today or even on homework, you can always visit my Facebook page at Tutor Me Sempai and tell me all about it there. This video is going to have 4 parts, so leave a like, smash the subscribe button, and let's get started. So today we're going to talk about how to find your standard deviation and your variance. However, we're not going to spend too much time on standard deviation. We're going to focus a lot more on variance because finding your standard deviation is actually quite simple. As long as you know how to find your variance, it's going to be the square root of that. So if you find your variance, square root it, you'll find your standard deviation. So that's pretty much all you really need to know about standard deviation, how to calculate it. So we're going to focus the rest of the time on finding our variance. Now, if I were to give you a bunch of numbers, let's say 4, 6, 9, 5, 7, 5, 8, 3, 6, and 7. If I was to give you all of these numbers and I told you to find the variance, that's not too difficult. As long as you have the formula, you can find your variance. However, before you find your variance, there's one thing you have to ask yourself about this list of numbers. You need to ask yourself, what do these numbers represent? You see, for variances, you can either have a population or a sample. They're very, very different things. Population or a sample. Now, what's the difference between them? Well, if this was your population, for whatever you're trying to measure, you can think of your population as all of the numbers that you need to measure. Like if anything you're trying to measure, you have every single number that you need. Everything's accounted for. That's your full population. However, for a sample, you don't need all of the numbers. You just need some of them. So if this represents a sample of a much larger population size, that's perfectly fine. It would just be a smaller group of numbers. But that's key because depending on what this represents, you're going to need to find a different variance. You either need a population variance or a sample variance. So if this, to give you an example, if this was your population, a sample could be 4, 6, 9, 5. It could be 5, 8, 6, 7. It could be 6, 7, 5, 3, 7. It doesn't really matter as long as you have some part of this overall population, a smaller number of them, that can be your sample. You're just taking out a smaller subset of the full population. So if this is your population, there are 10 numbers here. That means you're supposed to be measuring a total of 10 things. That's your full population size. So for example, let's say you went fishing and these were the number of fish you caught. Now, if you only went fishing 10 times, this would be your full population because there are 10 numbers here. If you went fishing 20 times, this is not going to be your population. This is a sample. This is only 10 numbers. You're not accounting for every single thing that you're trying to measure. So you have different variances, and it's important to know which one you're measuring because you have different formulas for each one. So let's jump into that. So once you've determined whether you have a population or a sample that your numbers represent, now you can start moving on to using or at least identifying your formula you need to use. So let's say you have a population. The formula for finding your population variance is as follows. You're going to have the sum as I goes to big N. You're going to have some parentheses here, x sub I minus mu over big N. And you're going to make sure you square that because your variance is going to be the difference. This is saying this is going to be the difference of your different data points, that's what this xi stands for, minus your mu, which is going to be your population mean. It's different than your regular mean. You have the full population accounted for. So this is going to be your mu, which is going to be your population mean. So you're going to have the difference between each data point and your population mean. You're going to square it and then divide it by the total number. This big N is the total number within your population. And once you sum up all of that, that's going to give you your variance, or your population variance, if you're being more specific. And it'll look like that. So this is your mu. That's going to be your population mean. And this is going to be your sigma squared. Sigma squared is your variance when you're dealing with a population. However, if you're trying to find your sample variance, it's a similar formula, but a little different. You're still going to be using your sum. You're still going to find a difference and square that difference. So this is going to be looking kind of the same, but you have to make sure you pay attention. Instead of going from I equals 1 to big N, you're going to go to small n. And that stays the same. But instead of using your population mean, you're going to find your sample mean, which is denoted by an X bar like this. And instead of putting capital N, and instead of putting a lowercase n, you're actually going to put an n minus 1. So this tells us for every data point in our sample, we're going to subtract the sample mean, we're going to square it, we're going to divide it by the total number of our sample minus 1, and that's going to give us our variance here. It's denoted by an S squared. Instead of sigma squared, it's an S squared. But this is also how you find your variance. So population variance, you use this formula. Sample variance, you use this formula. They look pretty similar, but there are some differences. Mu, your population mean. X bar, sample mean. You're dividing by a capital N, which is your total population number. You're dividing by n minus 1. This is not total population. This is going to be your sample number. And of course, your variances have different notations. So these are going to be the formulas that you're going to need when you're trying to find your variance. So let's jump into two examples so we can put these formulas to practice. So let's say we have this group of numbers here: 92, 79, 85, 89, and 80. And we're told that these are going to be math scores randomly selected from a group of math students' test scores. Now you have to ask yourself, if we need to find the variance and the standard deviation, what does this represent? Is this a population or is it a sample? Now, ignoring the fact that I have sample example up here, you should see that this is a sample because of the wording that you're seeing here. Randomly selected is kind of a tell that this is not the full list in your math class or a math class. There's probably going to be more than 5. There's no reason to say randomly selected if there were only 5 students. So the fact that I said these are math scores randomly selected lets you know that these are not everything. Not everything is accounted for, therefore this can't be the population. So we know which formula we're going to be using. I'll put it up here for reference. This is our formula because it's our sample variance that we're finding. Now all we have to do is plug it in and see what we get. So the first thing we need to do is find our sample mean. So our X bar. So let's sum up everything. And when we do 92 plus 79 plus 85 plus 89 plus 80, and we divide all of that by 5 because it's a mean, an average, we're going to get 85. So our sample mean in this case is going to be 85. So averaging all of that gives you an X bar of 85. Now we can plug into our formula or write it all out. We're going to have 92 minus 85 squared plus 79 minus 85 squared plus, it's going to be an 85 minus 85 squared plus 89 minus 85 squared plus 80 minus 85 squared. Had to squeeze that in. Not good space management. And it's going to be n minus 1. Now, n is what? N is going to be 5. That's what we use to find our sample mean. But this is going to be n minus 1. So it's going to be all divided by 4. So we're not dividing by 5, not the full sample size, one less than the sample size. And when we put all this in our calculator, we're going to get an s squared value of 31.5. So our variance in this case is going to be 31.5. And our variance is going to be s squared. So what's going to be our standard deviation? Well, that's just going to be the square root of s squared, which is just s. So what's our standard deviation? Let's find out what our square root of this is. So our s is going to be the square root of 31.5. And if you put that into your calculator and let's give it some rounding, you're going to get 5.61. Now there's more numbers here, but we're going to just stop it at 5.61. So our standard deviation is 5.61. Once again, you see that we don't have to spend much time on finding the standard deviation because once you find your variance, just find the square root. That's your standard deviation. But it is a little bit more involved trying to find your variance. So this is how you calculate your sample variance. Let's move on to our next example and see how we're going to find our population variance. Now in this example, we're going to find our population variance and our standard deviation from it. However, if I didn't tell you that this was the population example, how would you know? Well, you have a list of numbers, 40, 37, 42, 38, 46, 37, and 47. And if I told you that these numbers represent the speed of 7 cars that drove past a certain street, does that ring any bells? Does that sound like a sample or a population? I gave you how many numbers here? 1, 2, 3, 4, 5, 6, 7. And I told you these are the speed of 7 cars that drove past a certain street. Well, if there are 7 cars and I gave you 7 numbers, everything is accounted for. That tells you that this is going to be your full population. Everything that you're trying to measure is accounted for. So this is the population variance that we need to find. And I've given you your formula up here just for your remembrance. So let's first start with finding our population mean. So our mu is going to be summing up all of these things. So 40 plus 37 plus 42 plus 38 plus 46 plus 37 plus 47 divided by the full number of our population, which is going to be 7. And when we do all of that, you plug all of that into your calculator, that should give you 41. So our mu, our population mean, is going to be 41. So we can start there. Now that we know our population mean, let's plug everything into our formula and see what we get for our population variance. So 41. So now we have 40 minus 41 squared plus 37 minus 41 squared plus 42 minus 41 squared plus 38 minus 41 squared plus 46 minus 41 squared. Let's bring it around here. Plus 46. 37 minus 41 squared plus 47 minus 41 squared. And all of that is going to be over what? N. Our big N. What's our big N? 7. Because that's the full population number. The full population number is 7. All of this gets divided by 7 this time. Plug all of this into your calculator and you're going to get what? After rounding to the nearest hundredth, you're going to be left with 14.86. That's going to be your sigma squared. Our population variance is 14.86. 14.86 sigma squared. Now, in order to find our sigma, we're going to square root. And when we do that, we're going to be left with 3.85. 3.85 is going to be our standard deviation, which is our sigma. 3.85, our standard deviation. So I hope you were able to follow along with today's video, and I hope you now understand what you need in order for you to find your variance and your standard deviation. However, if you have any questions about what we saw today, or even your own homework, hit me up on my Facebook page at Tutor Me Sempai and tell me all about it there. If you hadn't done so already, hit that like. It surely helps the channel by letting YouTube know that you found the video helpful. And if you found a video helpful, so can someone else. So leave a like, hit the notification bell, smash the subscribe button, and share the video with a friend. Well, that's all the time I have for today. I'm really hoping this helped with your homework, and I'm looking forward to seeing you again next week. I'm Courtney, and this has been another session of Tutor Me Sempai.